Okay, a cricket question. A ball of mass 250 grams approaches a bat at a velocity of 144 kilometers per hour, and the ball was struck by the bat and it bounces off the bat. Find the force exerted on the ball by the bat during the following instances. So we are considering two different scenarios. All right. So first of all, mass of the ball is given, that is 250 grams. So M is in fact 0.25 kilograms. It's important that we convert everything to SI units. And then this is going to be our initial velocity. So U is equal to 144 kilometers per hour. That is, that must be actually converted to the SI units. So 144 into, we convert it by this equation, using this equation, 5 over 18. So that 144 and 18, if you simplify that, it will be 8. So finally 40 meters per second. You're getting that. So the ball is approaching at that speed towards the bat. So 40 meters per second, and that is our U. I hope you people are clear about that, right? So U and M settled, right? And in this question, V is given as 180. Okay, here you can see it's given as 180 kilometers per hour. So let's convert that to SI units. 180 into 5 over 18, 10. So that is 50 meters per second. That will be 50 meters per second, sorry. 50 meters per second, right? This one. And here it's the same final velocity. So V for this is 40 meters per second. Same, I wouldn't say velocity, same magnitude of velocity or same speed, right? Okay, so if you consider the first part, what is happening? Now I'll draw it from side V. Okay, side V. So let's say you are seated in the pavilion. You're one of the spectators at square leg, if not deep point cover in that region. So when you watch, the bat will be like this. Ball is approaching the bat at a velocity of 40 meters per second. All right, and then it is bouncing off the bat at 50 meters per second. It's bouncing off the bat like this. This is our V, and this is U. This is U. All right, fine. Now for this case, if you apply the equation, Newton's second law, F is equal to mv minus mu divided by t. Okay, again, let's take mass out as common, v minus u over t. All right, fine. So here, people, if for the force, there are a lot of vectors here, so we have to define a direction. I'll use this direction because the ball is eventually going to the right. So the bat must have exerted a force in that direction. Then only ball will go in that direction. Okay, so right, so it's like a straight drive. Ball is coming towards the back, straight drive, goes again towards the baller. It might have been a catch or four, I don't know. So now let's apply. F is equal to mass of the ball is 0.25 within brackets V is 50. I can direct the substitute number 50 minus, for U I have to substitute minus 40. If you put 40, it's incorrect. It should be minus 40 because we are applying the equation to the right, but U is towards left. So there are two minus signs. This minus is this minus, and this minus is for the direction of U. And divided by, first question, time of impact is 0. Okay, so we have to be a little careful there. 0.25 into 90 by 0.2. 90 by 0.2. All right, so that can be written as, how do you finish it off? 900 by 2. 900 by 2. So that is 250. So F is equal to, now I don't like keeping things in decimals. 0.25, you can write it as 104. Correct? 104 into, this is 900 over 2, so 450. So let's divide 450 by 4. That's easier than multiplying by 0.25. So whatever, you get the answer somehow. When you divide 450 by 4, it will be 112.5 Newton. And that is in this direction according to the diagram I have drawn. According to the diagram I have. So this is the ball. It bounces off the bat like this. So for the first question, the answer must be 112.4. 112.5. Sorry. And the next one, for the second part, now we have to see from the top. I'm going to take the top view. Let's say there's a drone flying and the drone is observing, because it's moving perpendicular. So I don't know how much you guys know cricket. It's a cut shot. Ball is coming towards you. You hit it perpendicular. That's called a cut shot. So I'll draw it like this. That maybe the bat goes like this. The ball is coming towards the bat, right? The ball is coming towards the bat, and it's rebounding like this. Okay, right. So initial velocity 40 meters per second, and for the next question it says it bounces off the same speed. So it bounces off 40 meters per second. It was a cut, so the ball goes like this, perpendicular. All right, fine. And then for this, now this is our u and this is our v, right? And the time of impact is 0.1 second, right? So let's apply the equation quickly. F equals mv minus mu over t. Take m out, that gives us u v minus u. I'll take F is equal to for mass 0.25, and for u, okay, time, like for u, sorry, v is 40 in this direction, minus u is 40 upwards, divided by time, 0.1. Okay, so this can be written as 0.25 over 0.1, that is 25 over 10. So I can write as 5 over 2, inside the bracket 40 in this direction plus 40 down, because we can add conveniently 40 down, right? So we have to do the vector addition there now, 5 by 2, 40 and 40 like that. So how do you draw? You can draw the vector addition. So first you draw one vector at 40. From the finishing point, you can draw the other vector, 40. So the resultant of those two will be along this direction. All right. So when you have 40 and 40 perpendicular to each other, what is the resultant? 40 root 2. That would be the result. Okay. So here you can't just add 40 and 40. You have to be careful. The directions are different. So final answer 5 over 2 into 40 root 2. 40 root 2. That will be now see 2 and 40 will be 20. 20 into 5 is 100. So that is 100 root 2. And for root 2, we can substitute 1.4, and that will give us 140 Newton in this direction. 140 in this direction, and it will be the angle here. This angle is theta, and we all know theta must be equal to 45. So magnitude and the direction also must be given, because yeah, here we could not apply the equation in a specific direction because v and u were in different. One is horizontal, one is vertical. All right. So the answer is 140.